Welcome to Spy Math. This is Mr. Spy, and this will be August 2018 Geometry Regents Part 2. Okay, let's begin. Question 25. The circle below, segment AB, is a chord. Using a compass and straight edge, construct a diameter for the circle. Leave all construction marks. Okay, so let's upload the circle. Here's our circle. Now we take the point of our compass, bring it to point A, open the compass to point B, make a mark. Oops, not perfect. Do that. Open a little wider. Make a mark on point B. Actually, it's too wide. That's perfect. Let's make the mark. She's still too wide. It's hard to get the exact spot here. Here, perfect. At point B, make a mark. Make a full semicircle. Mark above, mark below. Repeat the process with the point of the compass on B. So you have a semicircle from both sides of the segment. Then you'll see at the segment, those two arcs intersect above and below. Take your ruler, line up those two intersection points. Draw a straight line from the top. Oops. Straight line all the way to the end of the circle. And there you have it, the diameter of the circle. Using this diameter because it's a perpendicular bisector of the segment AB. On to question number 26. Question 26. In parallelogram ABCD shown below, the bisectors of angle ABC and DCB meet at point E on segment AD. The measure of angle A is 68 degrees. Determine and state the measure of angle BEC. Now we need to find the measure of the angles that are bisected. So the angles on this side add up to 180 on side AB. So the bottom angle is 68 degrees. So 180 take away 68 is 112 degrees. 112 degrees divided by 2 gives you these two angles that are 56 degrees. And now to the other side, angle C. Angle A is the same as angle C because opposite angles of the parallelogram are congruent. Divide 68 by 2, you get 34 degrees. So those two angles are 34 degrees. Now find the angle we want, E. You see the math that 180 is the sum of the triangle minus 56 plus 34. Add those two angles together, you get 90 degrees. 180 take away 90 degrees is 90 degrees. So the measure of our expected angle is measure of angle BEC, which equals 90 degrees. On to question 27. Sorry for the error there. Okay. Spin up a little bit before you get to the answer. Now, in circle A below, chord BC and diameter DAE intersect at point F. The measure of arc CD is 46 degrees, and measure of arc DB is 102 degrees. What's the measure of angle CFE? Now we need two arcs I'm circling in red. This one we need, and this one we need, and this one we need. We don't actually need the one in red. Over here I'm going to erase the 78. That's not important information. Now we need the two arcs we circled in red. Now, to find the first one, we know 180 take away 102 degrees will give you 78 degrees, which you don't need. But the other one, to get arc CE, take 180 from the 46, and we get 134 degrees. Now we need these two arcs, this one and this one. Just the opposite, the two vertical angles formed by the chords are the same. Just take the sum of those two arcs, 102 plus 134 degrees. You get 236 degrees. You divide by 2. Once you divide by 2, you have 118 degrees, making our arc 118 degrees. So angle CFE is 118 degrees. On to the next question. Trapezoids ABCD and A double prime, B double prime, C double prime are graphed on the set of axes below. Describe a sequence of transformations that map trapezoid ABCD onto trapezoid A double prime, B double prime, C double prime. So you map the distance of one point. A started at -3, 2. Then it traveled to 3, -2 at the rotation of 180 degrees at A prime. Then you move down 2 more to get the 3, -4, which is the position of A double prime. And this is the way sequence can be written out. Conclusion. Rotate trapezoid ABCD 180 degrees about the origin. Don't need to specify as clockwise or clockwise because 180 degrees doesn't matter. Then translate the trapezoid 2 units down to get trapezoid A double prime, B double prime, C double prime, D double prime. On to the next question. Question 9. In the model below, support wire for a telephone pole is attached to the pole and anchored to a stake in the ground 15 feet from the base of a telephone pole. Jamal placed a 6-foot wooden pole under the support wire parallel to the telephone pole, such that one end of the pole is on the ground, the top pole is touching the support wire. You measure distance between the top pole and the stake in the ground. Jamal says he can approximate how high the support wire attached to the pole using similar triangles. Explain why the triangle is similar. The numbers don't really matter. You're just using the fact that there's a right angle here and a right angle here, and that both triangles share this angle that I'm marking off in green and circling green, and that makes use the angle-angle similarity theorem, and this is how you can write your conclusion. The triangle is similar by angle-angle similarity theorem. This little squiggly line means similarity. Since both triangles are right, since both triangles have, let me fix that for a minute. Since both triangles have right angles and all right angles are congruent, also, let's make it a capital A, put a comma there. Also, both triangles share the angle made by the support wire and the stake. Therefore, both triangles contain 2 corresponding congruent angle pairs, making the triangle centered by angle-angle similarity theorem. It's not a bad idea to put in parentheses right here that this is the reflexive property, since we're saying the same angle equals itself. This is sort of a proof. Therefore, both triangles contain 2 corresponding angle pairs, make the triangle similar by angle-angle similarity theorem. We need 2 pairs of corresponding angles. Therefore, the sides are proportional. Jamal can find how high if the sides are proportional. Therefore, Jamal can find how high the height of the support wire is. On to the next question. Question 30. Aaliyah says that when line 4x plus 3y equals 24 is divided by a scale factor of 2, center the point 3, 4 of the equation, but dotted line y equals -4/3 x plus 16. Is Aaliyah correct? Explain why. The use of the axis below is optional. I will use them at the end. So now you take your equation and solve for y. 4x plus 3y equals 24. Subtract 4x on both sides. You get 3y equals -4x plus 24. Divide everything by 3. So that's -4/3 x plus 24 divided by 3, which is 8. Then you take your point, plug it in, and see if the point that you're dialing around is on the line, because the point you're dialing around the line, it's on the line, it will not change. So y equals -4/3 x plus 8, x equals 3, y equals 4. So -4/3 of 3 is -4. -4 plus 8 is 4, so 4 equals 4. Therefore, the center dilation is on the preimage. Therefore, our conclusion. Ali is wrong since the point 3, 4 is the center of dilation, and this point is on the original line, the preimage. Center of dilation is on the original line, the preimage. The scale factor has no effect on the line. So if you want to see that's on the line, you also do it by graphing. Hold on one second, I'll graph the line. Okay, now here's the graph of the line. Here's the one set at 8. Here, marked in red, is the center of dilation. Since the dilation is on the line, we do not dilate the line at all. On to the next question. Ian needs to place 2 concrete sections in a sidewalk. As modeled below, each section is 36 inches by 36 inches and 4 inches deep. He can mix his own concrete for $3.25 per cubic foot. Remember, it's inches that they changed to feet. How much money will it cost Ian to place 2 concrete sections? So first we find the volume, which is 36 times 36 times 4, because volume is length times width times height. This is our length. This is our width. This is our height. Once you find the volume, which is 5,184, divided by 12 cubed to convert the length, width, and height into feet, which is 1728. 5,184 divided by 728 is 3. Multiply 2 for the 2 concrete sections. Get 6 cubic feet. Then you multiply by the cost of each cubic foot, which is $3.20. $3.20 times 6 give you the cost of $19.50. Make sure to put the 0 because it is a cost. Now, before I show you how to do this on the calculator, to wrap up, you can see how to input it into the calculator neatly to confirm your answer. So we take up our calculator, turn it on, do it slowly, do it all in one step, very conveniently. Hit alpha, y equals to get the fraction. Numerator, put 36 times 36 times 4. And then I put 12. Raise, use the button above the division sign to get the power, 12 to the 3rd power. Multiply that whole thing by 2, because it's 2 concrete sections. Multiply that whole thing by the cost of $3.25, and you should get 19.5. Remember, you should write your answer with 1 decimal place because it's money, so it's $19.50. That's the end of part 2 on the August 2018 Geometry Regents. It's also the final video of the 6 videos on the August 2018 Geometry Regents. If you like this video or you like any of my videos, please hit like below. Also, please subscribe to my channel. There will be postings of more Regents. The next one will be the June 2018 Regents, hopefully coming out before the August 2019 Regents this year. Also, I'm making more Geometry Regents throughout 2019-2020 school year and doing maybe Algebra 1 and Algebra 2 Regents by request. If you have any math topic from middle school math to high school math to college math you'd like me to make a video of, please comment below. If you like this video, also hit like and comment below. This will be Mr. Spicer, known as Mr. Spy, signing off.